Welcome back to Future Bond's AI and Humans.
Today's episode is about the magic behind AI, which lets machines understand human language, natural language processing, or NLP.
So what is natural language processing? It's how machines read, interpret, and generate human language.
Natural language processing, sometimes known simply as NLP, is a subfield of artificial intelligence that investigates how computers and people communicate with one another through language. Understanding, analyzing, and producing human language in a format that is comprehensible to computers is the focus of NLP, which is a subfield of computer science. Speech recognition, natural language comprehension, natural language production, and machine translation are all subfields that fall under the umbrella of NLP. The following are some examples of fundamental NLP tasks. Tokenization refers to the process of slicing a text into its component words, phrases, or sentences. POS tagging is the process of giving a specific grammatical label to each word in a sentence, depending on the role that word plays in the sentence. The process of locating and categorizing named entities inside a text, such as persons, locations, and organizations, is referred to as named entity recognition, NER. The process of determining the emotional tenor of a piece of writing, whether it be positive, negative, or neutral, is referred to as sentiment analysis, which is the process of translating text from one language into another using a computer program. The use of machine learning methods, especially deep learning techniques such as neural networks, is essential to the practice of natural language processing, NLP. These algorithms are trained on enormous datasets of text, which enables them to understand patterns and structures in natural language and make predictions based on them. The training can take place on a computer or in a cloud-based environment.
Bridges, computer science and linguistics, helping machines read between the lines when we text, speak, or type.
Ever wonder how your smart assistant understands "remind me to call mum after dinner"? That's NLP at work.
Hey Google, remember that tomorrow I have a meeting at 8 a.m.
Got it. I'll remind you tomorrow morning.
It figures out your intent, extracts time and context, and schedules the reminder, all in milliseconds.
NLP is built on several layers like tokenization, syntax parsing, and semantic analysis.
Ever wonder how machines understand language? Let's break it down into 3 simple steps. Step 1, tokenization, breaking down text into words or tokens. Step 2, syntax analysis, understanding the grammatical structure. Step 3, semantic analysis, grasping the meaning behind the words. And there you have it, the NLP pipeline in action. It's like teaching a machine to read between the lines. Now, go impress your friends with your new knowledge.
Tokenization breaks your sentence into words. Syntax parsing maps grammar. Semantics finds meaning.
What is a tokenization in NLP? In natural language processing, NLP, tokenization is a fundamental technique used to break down a paragraph or a sequence of text into smaller units known as tokens. These tokens can be individual words, subwords, or characters. The purpose of tokenization is to transform raw text into a format that can be easily understood and processed by machine learning algorithms.
Behind it all are AI models trained on huge language datasets, like GPT or BERT.
BERT versus GPT. Both are derived from the transformer neural network architecture that can convert sequences to sequences. A sequence is typically an ordered set of data, and in natural language processing, this could be a set of words to form a sentence. BERT and GPT specifically focus on natural language. As far as their architecture is concerned, BERT is a stack of transformer encoders and the GPT is the stack of transformer decoders. Both are pre-trained to understand language, then fine-tuned to understand a specific task in that language. So BERT, for example, is pre-trained on natural language inference and sentence text similarity, whereas GPT is pre-trained on the language modeling objective of predicting the next word in a given sentence. They are then both fine-tuned with supervised data, although GPT can alternatively use meta-learning to make decisions without fine-tuning.
These models don't just memorize, they learn context, idioms, tone, even sarcasm.
Let me introduce you to GPT and BERT, the neural network wizards. These models don't just memorize, they learn context, idioms, tone, even sarcasm. Imagine a machine that gets your jokes. It's like having a conversation with a friend who knows you well. So, next time you chat with AI, remember, it's not just smart, it's savvy. Which part of AI's understanding amazes you the most? Or are you just impressed it can keep up with your humor? Be honest.
So now you know the basics. NLP isn't just magic, it's layers of smart technology.
In Part 2, we'll explore how NLP shows up in real life and some of its challenges. See you there.
Thanks for watching FutureBond's AI Humans. What's next? Let us know your thoughts in the comments. Don't forget to like, share, and subscribe for more AI insights. See you in the next episode.